Hey everyone, Kyle from LightStanza here, and today we're going to be talking about LightStanza's enhanced linear functionality. The LightStanza plugin has a streamlined approach to the proration of linear fixtures in Revit, where upon import to LightStanza, each linear fixture will have the correct output and length. There are two parameters we use to control the output and the length of each linear in Revit. The two parameters in Revit are LS-luminousLength and LS-IES Basis Length. LS-luminousLength controls the length of the luminous dimensions of each linear fixture. LS-IES Basis Length controls the scaling of the output of the IES file. There are three different workflows to use the LightStanza parameters in Revit to prorate linears in LightStanza. We have three ways so people of various knowledge can work effectively in Revit. The first way is the manual way, the second way is the semi-automatic way, and the third way is the automatic way. Before we can go through and show the manual, semi-automatic, and automatic way, we have to load the LightStanza parameters into Revit. So to do that, in Revit, in the LightStanza tab, we'll go over to the button Load LS Parameters. And this button will load the LightStanza parameters into this Revit project. And now we're ready to go ahead and show the manual way on how to prorate our linear fixtures in Revit. There are two different linear fixture types in Revit, fixed-based linears and instance-based linears. To show the manual way, we're first going to look at a fixed-based linear. The type on the screen, LO3, is a fixed-based linear, which means that its length is the same for all instances of its fixture type. To set the LS-luminousLength parameter for this fixture, we go over here to the left and we see LS-luminousLength. We want the value of this to equal the length of this fixture. So for LO3, the length is 4 feet. So we're going to want to enter in 4 feet here. And we can confirm that this is 4 feet by going to Edit Type. And we can look at our custom length parameter and see that it is 4 feet. The next parameter we want to set is the LS-IES Basis Length. And that value needs to equal the length of our IES file. And so our photometric web file, we can see is 4 feet. And so on the basis length, we want to enter in 4 feet. And hit OK. In this case, since the linear fixture is 4 feet and the basis length is 4 feet, there will be no scaling or prorating of the IES file. When you have a 6 foot or 8 foot or 12 foot fixed linear, then the IES file will be scaled and prorated correctly. The next type we're going to look at is the instance-based linear fixture in Revit. Type LO2 is an instance-based linear fixture, which means that it has one fixture type, but its length can change for each instance of the fixture type. And we can see that here by if I drag this, the length changes, and on the left over here we see custom length, and it changes as I move this. Now it's 11 feet. So we want our LS-luminousLength equal the value of our custom length. So we just go ahead and enter in 12 feet here. And then we'll go ahead and set our IES basis length, which we want to be 4 feet. And hit OK. And so now, for each linear fixture type that is instance-based, we're going to have to go ahead and set the LS-luminousLength to the fixture length. And that is the manual way of prorating linear fixtures in Revit. Using the first way, the manual way, entering in the data for the luminous length parameter on every fixture instance gets very tedious. The second way provides a streamlined approach to entering this data. So we go and look at the LightStanza tab, we see the Copy to LS-luminousLength tool. This will go ahead and copy the value from our custom length parameter right here into our luminous length parameter. So we'll go ahead and we'll put 8 feet here. And then I'll go ahead and I'll find in my list of parameters my custom length parameter. and I'll click on Copy to LS-luminousLength. And we'll select this LO2, and we'll see that now it's changed to 12 feet. Now this tool is a copy-paste tool, so if I change my length here, it's not going to update my luminous length. You can now see that you have different values. So I would just have to go ahead and rerun this tool. And now it's the same. The next tool we provide is the Set LS-IES Basis Length. This is going to look at the IES file associated with your fixture type and set the value for the LS-IES Basis Length. This does not have to be the IES file you're going to use in LightStanza. It just has to be a placeholder IES file in Revit. So we'll go ahead and we'll change this to 2 feet so we can show this working. Go up to the LightStanza tab and press Set LS-IES Basis Length. And now we'll go back to the edit type, and we see it's changed to 4 feet. So that is the semi-automatic way of prorating linear fixtures in Revit for export to LightStanza. I'm now going to demo the third way, the automatic way of linear proration in Revit. For a how-to video on how to set up the automatic way, please refer to the link below. So in Revit, with the lighting fixture selected, we're going to look on the left over here, and we see that luminous length is grayed out. And so in the first way, the manual way, I had to enter in the value into luminous length of my linear length. And in the copy to LS luminous length, I was copying the value of my custom length parameter into my luminous length parameter. In the automatic way, as I change the length of this linear, the luminous length updates the length of the linear automatically, and it equals the custom length parameter. And so I no longer have to enter in any data into the luminous length parameter, and I don't need to run the copy to LS luminous length tool anymore. I'll show that again. If I press N40, luminous length is updated. And if I go and select these other fixtures, we can see that custom length is 44 feet, and that equals luminous length. And we'll go ahead and we'll make this shorter, and now luminous length has been updated. Now that we've set our luminous length parameter and our basis length parameter, we're going to go ahead and export to LightStanza and see this in action. So we'll go up to Export to LightStanza, and we'll go ahead and export. Now that we've exported to LightStanza, we can see that we have two types here, LO1 and LO2, and they have been prorated and scaled correctly. And we can verify that by, if we zoom in here, we can see this type here, this blue box that is going along with the fixture geometry is the luminous dimensions. And for each length, we can see that it changes. We can also click on a fixture and go ahead over here to the left and click Manage Instances. And we can see the proration factor that is applied to each instance of this fixture type. We can also go ahead and click on Edit IES File, and we get a note in our family editor that some instances have a proration factor assigned. The output will be scaled accordingly. And so that is how we can verify that our proration is being correct upon Revit to LightStanza.